There are things your ancestors built that you cannot build today, not because the tools do not exist, not because the materials are gone, but because somewhere between then and now, the knowledge simply vanished. And the harder modern science looks, the stranger the silence becomes. These are not myths. These are not legends passed down by people who misremembered things. These are physical objects you can touch, structures still standing after 2,000 years, and formulas that engineers with billion-dollar budgets have spent decades trying to reverse engineer, and they still cannot fully crack them. Here are 5 technologies from the ancient world that modern science still cannot completely explain. Number 1. The Antikythera Mechanism. In 1900, a group of sponge divers off the coast of a small Greek island called Antikythera discovered a shipwreck on the seafloor. Inside the wreck, buried under coral and sediment, was a lump of corroded bronze roughly the size of a shoebox. Nobody thought much of it at first. But when researchers began cleaning the object, they found something that should not have existed. Gears. Dozens of interlocking bronze gears, precisely cut, layered on top of each other with a complexity that no one expected from an object dated to roughly 100 BCE. This was a machine, a calculating machine. An analog computer built more than 2,000 years before the concept of a computer existed. Historian and science writer Joe Marchetti described it as finding a jet engine in the tomb of Tutankhamun. That is not an exaggeration. This mechanism could track the movement of the sun and moon, predict solar and lunar eclipses with stunning accuracy, calculate the timing of the Olympic Games, and model the motion of at least 5 planets. All of this through a hand-cranked system of interlocking bronze gears small enough to hold in 2 hands. Here is what makes this truly disturbing. After the Antikythera mechanism, there is a gap in the historical record of roughly 1,000 years before anything of comparable mechanical complexity appears again. 1,000 years. Whatever tradition produced this device did not survive. Whatever school of engineering built, it left no students, no manuals, no descendants. Researchers at University College London spent years using advanced 3D X-ray scanning to map every gear inside the mechanism. In 2021, they published a reconstruction of the front plate. It was extraordinary, and it raised more questions than it answered, because even with the best imaging technology available today, there are still parts of the mechanism that no one fully understands. A device built 2,000 years ago is still outpacing the tools used to study it. Number 2. Damascus Steel. For roughly 1,000 years, between 300 CE and 1700 CE, swordsmiths in the Middle East produced a blade unlike anything the world had seen before or has fully reproduced since. Damascus Steel, named after the Syrian city through which it was traded, though it was likely forged in the Indian subcontinent from a material called wood steel. The blades were legendary. Crusaders who encountered them reported that a Damascus steel sword could slice through a falling silk scarf, could cut the edge of a European broadsword in half, could hold an edge that modern high-carbon steel struggles to match. The surface of a Damascus blade was distinctive, flowing wavy patterns, almost organic, rippling across the metal, beautiful and terrifying at the same time. Then, around 1750, the technique died completely. The Indian ore sources that produced the specific Wootz ingots began to run dry. The master smiths who held the knowledge either died without passing it on or deliberately kept the formula secret. And within a generation, the ability to make true Damascus steel was gone. Modern metallurgists have spent decades trying to recreate it. And here is where the story becomes genuinely strange. In 2006, a team of researchers led by Peter Poffler at Dresden University of Technology examined Damascus blade samples under a microscope and found something no one had expected: carbon nanotubes, structures so small they require an electron microscope to see, structures that materials scientists only discovered and began studying in the late 20th century. The ancient smiths were producing carbon nanotubes accidentally through their forging process, and those nanotubes were likely a major reason for the blade's legendary strength and flexibility. They had stumbled into nanotechnology without knowing it existed, and no one today has worked out exactly how to reliably replicate the conditions that produced them. Number 3. Greek fire. Sometime around 672 CE, the Byzantine Empire deployed a weapon that changed naval warfare forever: Greek fire. a liquid substance that could be projected through a tube mounted on the bow of a ship, igniting on contact with its target, burning ferociously on the surface of water, and, most terrifyingly, impossible to extinguish with water. In fact, water appeared to make it burn more intensely. Contemporary accounts describe entire enemy fleets reduced to floating ash. Arab naval forces, who had never seen anything like it, called it liquid fire from heaven. The Byzantine Empire used it to repel multiple Arab sieges of Constantinople, and the formula was kept so secret that it was classified as a state secret at the highest level. Emperors swore oaths to never reveal it. The knowledge was supposedly held by a single family and passed down only within that bloodline, and then it disappeared. By the 13th century, accounts of Greek fire fade from the historical record. The formula was lost, and despite centuries of attempts, no one has definitively reproduced it. Modern chemists have proposed candidates. Historian John Halden and chemist Byrne have suggested it may have been a mixture of quicklime, petroleum, and possibly pine resin. Chemist and historian of science J.R. Partington spent years analyzing Byzantine accounts and proposed formulations involving crude oil distillates, but every proposed recipe falls short in at least one crucial way. None of them fully replicates the behavior witnesses described. None of them burns on water the way accounts specify. None of them can be reignited after being extinguished the way Greek fire reportedly could. The closest modern equivalent is napalm, developed in 1942 with the resources of the American military behind it. And even napalm does not fully match the ancient descriptions. Something in that formula remains missing. Something the Byzantines took with them when their empire fell. Number 4. Roman concrete. The Pantheon in Rome has stood for nearly 2,000 years. Its dome, made entirely of concrete, is still the largest unreinforced concrete dome on Earth. The port structures built by Roman engineers in harbors across the Mediterranean are still there, largely intact after 20 centuries of tidal battering, saltwater, and seismic activity. Modern concrete, by comparison, begins to degrade within 50 years. Coastal concrete structures crack and crumble within decades. The concrete holding together bridges and seawalls built in the 20th century is already failing across much of the world. So what did the Romans know that we do not? For a long time, historians assumed Roman concrete was simply good stone masonry dressed up with a binder. Then, in 2017, a team of researchers led by Marie Jackson at the University of California, Berkeley, published findings that changed the conversation entirely. Roman concrete, particularly the maritime concrete used in harbor structures, was not simply resistant to seawater. It was actively strengthened by it. A rare mineral called tobermorite was crystallizing inside the concrete matrix over centuries, filling microscopic cracks as they formed, essentially allowing the concrete to heal itself. This process was triggered by the interaction between seawater, volcanic ash from a region near Naples called Pozzuoli, and lime. The Romans were not just building with concrete, they were building with a living material, one that got stronger over time rather than weaker. Jackson's team spent years trying to recreate the formula. They made significant progress, but the volcanic ash from the specific region the Romans used has particular chemical properties that are not easily sourced or replicated at scale. Modern construction relies on Portland cement, invented in the 19th century, which cures quickly and works at industrial scale, but begins degrading almost immediately. Switching the global construction industry to a Roman-style formula is not straightforward. The materials are not universally available. The curing time is far longer, and there are properties of the original Roman mixture that researchers still do not fully understand 2,000 years later. The most advanced civilization in modern history is still trying to catch up to builders who used wooden tools and ox carts. Number 5. The Baghdad Battery. In 1938, German archaeologist Wilhelm König was working in the basement of the National Museum of Iraq in Baghdad when he came across a small clay jar that had been sitting in storage, largely ignored since its discovery near the village of Kujut Rabu. The jar was roughly 14 centimeters tall. Inside it was a copper cylinder. Inside the copper cylinder was an iron rod. The iron rod was separated from the copper by an asphalt stopper at the top of the jar. König recognized what he was looking at, or thought he did. The object, dated to somewhere between 250 BCE and 250 CE, had the exact structural configuration of a galvanic cell, a battery, Fill the clay jar with an acidic liquid, grape juice, vinegar, lemon juice, and you have a working electrochemical cell capable of generating a small but measurable electric current. He published his findings. The scientific community was skeptical. The jars had no wires, no evidence of a circuit, no connective tissue linking them to any electrical application. But the experiments were run anyway. In 1940, Willard Gray at General Electric filled a replica of the Baghdad Battery with grape juice and measured a voltage output of approximately half a volt. More replicas were built. More tests were run. The devices worked as batteries, consistently. What remains unanswered is the purpose. Archaeologist and historian Paul Craddock at the British Museum has noted that objects found near similar jar configurations sometimes showed traces of thin metallic coatings that could suggest electroplating, using electrical current to deposit a thin layer of one metal onto another. Gold plating, silver plating. If that interpretation is correct, then ancient craftsmen in Mesopotamia were using electrochemistry nearly 2,000 years before Alessandro Volta officially invented the battery in 1799. The mainstream scientific community remains divided. Skeptics argue the structural similarity to a battery could be coincidental, that the jars may have held sacred scrolls or been used for storage, that without a clear circuit, the battery hypothesis remains unproven. But here is the thing that stays with you. The design works. Every time someone builds a replica and fills it with vinegar, electricity flows. Whether or not the ancient craftsmen understood what they were doing, they built something that functions. And that is a question no one has satisfactorily answered. 5 objects, 5 techniques, 5 formulas, each one from a civilization that had no satellites, no electron microscopes, no research universities, no industrial supply chains, and each one still holding at least one secret that the modern world has not fully unlocked. The assumption has always been that history moves in one direction, that knowledge accumulates, that each generation knows more than the last, that progress is a straight line moving forward. But these 5 things suggest something more complicated. They suggest that knowledge can be fragile, that it can vanish, that an entire field of expertise can disappear inside a single generation if the conditions are right. It has happened before, more than once. And what the Antikythera Mechanism, Damascus Steel, Greek fire, Roman concrete, and the Baghdad Battery all share is this. They are proof that the story of human knowledge is not a straight line. It is a map with missing territories, with roads that were built, traveled, and then swallowed back into the forest. And somewhere in that forest, the answers are still there, waiting for someone who knows how to look. Subscribe to our channel to learn more facts.